Guys and girls, it's know it time!
Alright, so today I just want to review with you and go over some extra questions on solving radicals. Review. And I want to go over two questions in particular and some fractions, because a lot of you went online yesterday and said, Mr. No, how do you do 7C, 6C, 6D and all that stuff? Review, radicals. So today is a review day. After the break, we are going to start your last bit. So guys, here's your review. I want to start with number 1 first on your exam question. Some of you had trouble with this. Root n minus 1 plus 7 equals to negative 14. Okay. Now, the whole point of this is really to get the square root by itself. Now, there are two numbers just floating around. The plus 7 and the minus 3. You have to get rid of both numbers right now. So let's just move it slowly. I'm going to move this over here. But before I do that, let's solve for my restriction. So restriction should be n minus 1 is greater or equal to 0. N is, I give you 1 mark if you say that is your restriction. Okay? So now that gives you negative 3 n minus 1 equals to negative 21. Here's where I noticed people had issues. They asked Mr. No, how do you bring that negative 3 over? Okay, and that's where that a lot of people ran into trouble. Harneet, how do you bring it over? You divide it by negative 3. See, if I divide it by negative 3, look what happens. It turns out very nicely. You get a nice 7. Now, I can square both sides. N minus 1 equals to 49. Guys, n equals to 50. Was it that hard? No, not really. Okay. But another more challenging question I want to go over with you was number 2. You should have 2 answers, 10 and 3. One of them was a reject. Yeah, well, yeah, no, you just cross out or whatever. But just read which one was your reject. 3 was a reject, which is correct. Okay. And then, but I want to go over some fractions. This is why I want to go over fractions today. You want to do that question? Yep. So if you want to go, I just go and set up the question, and you can actually try it later on your own. 5 plus 3x minus 5 equals 2x. Okay. Again, the whole goal of this is to get the radical on one side and try to remove all this lonely constants to the other side. Okay, the whole reason because I want to square both sides. When you did this, you get 3x minus 5 equals to x minus 5. So guys, go ahead and square both sides right now. I'm going to show you some neat shortcuts. Squared, and the shortcuts you probably learned in grade 10. If I square the left side, a lot of you says, hey, Mr. That's easy, that's 3x minus 5. If I square the right side, now here's what I noticed the majority of students will do. They go x minus 5, and they FOIL this out. It works perfectly fine. I have no issues against that. But back in grade 10, your teacher may have taught you a shortcut method. The shortcut method is this. You're going to square the x, whatever that is. That's x squared. You're going to leave a little gap. Okay. Then, you're going to square the last term right now. So go negative 5 squared. That gives you positive 25. Only thing that's missing is that what goes in the middle. To get the middle piece, you take 2 times negative 5 times x. Okay. And that gives you negative 10x. Like I said, you can try using the shortcut method, or if you want, you can do the long method. Up to you. I'm not move everything to one side. X squared minus 13x plus 30. Factor it out. x minus 10, x minus 3, x equals to 10, and 3. This will be your reject. Or more importantly, there's a mathematical term for this. Jessica, what's that term called? There's a mathematical term for a reject. It starts with an E. X, just like you had extraneous. Know this term, please. Extraneous root. Okay. I have to look at your work. So I can't comment on it yet until I see your work. I have, like I said, I have to look at your work. Now, another question a lot of you had issues with was the very first one. It was 5 12x. And I asked you to rationalize the denominator. I walked around, I think around 4 people did this. Okay, not to make fun of you or anything, but I want to show you where you went wrong. Okay. The problem with this is this. There's no square roots here. When you rationalize the denominator, there has to be some sort of square roots. So we know this doesn't work. What you can do is, let's break this down into 2 separate square roots. You can write this as root 5 over root 12x. It works both ways. If you have one big gigantic radical, chop it up into 2. Guys and gals, now rationalize this. So you go times root 12x root 12x. Okay? That gives you root 60x over 12x. Some of you circle this. You're not done yet. You got one more step to do, and that is to simplify the top part right here. Take a minute, simplify that part on your own. Nothing too bad. If you simplify the top part, you should get 2 root 15x over 12x. You're not done yet either. Cross out the 2 and the 12, which gives you root 15x over 6x. Now, a student will ask, Mr. Noel, can I cross out that x and that x up here? The answer is no. That's your final answer right there, root 15x over 6x. Okay? But, let's go over some tough stuff. That was too easy, so. This one? Really? That was hard? Alright, let's go over this one. 7 root 2 over root 6 plus 8. The question asks you to rationalize the denominator. I'm going to pause it, and I want you to if I look at this, right off the bat, I see root 6 plus 8. So I know I can't just do times root 6 times root 6. It has to be a bit more complex than that. It's going to be root 6. Darsha, what's after root 6? Ah, that's what I'm looking for, minus 8. Root 6 minus 8. Let's just work with the bottom. If you FOIL the bottom, you should get 6 minus 64. If my math is correct. Now, how did I get that? Well, that's easy. I went root 6 plus 8 times root 6 minus 8. If you FOIL this out, you get 6 minus 64. But let's worry about the top part right now. If I look at the top part, I have 7 root 2 times root 6 minus 8. So let's just FOIL this out right now. FOIL. So that gives me 7 root 12 minus 56 root 2. The problem is this, we're not done yet. We can simplify a lot more. So let's simplify. If you look at this one, 7 root 12. Guys and gals, break that down even farther right now. 7 root 12, break it down for me, please. 14 root 3 is correct. So that becomes 14 root 3 minus 56 root 2 over negative 58. Some of you will leave it right here. I may be kind and give to you, but you can do one more thing to it. Divided by 2. See, all these numbers, all the coefficients right here, you gotta look at the coefficients only. You can't look at the radicand, only the coefficients. All of these numbers can be divided by 2 very nicely. So your true and final answer should be 7 root 3 minus 28 root 2 over 58 divided by 2. Harmeet, question. Oh, I'm going to show you why. Okay. 58 divided by 2 is going to be 29. So far, so good. Negative. Now, somebody says, Mr. No, when I look at the back, the answer is negative. Why is that the case? Here's the reason why. What the back of the book does is they take this negative and they put it up here. They put it up here. If you put the negative up there, look what I'm going to do. I go negative. All this is in brackets right now. Minus 28 root 2 over 29. That's what the back did. And they multiply in this negative. Okay. You can leave the negative on top or in bottom. You choose. It doesn't matter to me. So 28 root 2 over 29. See the back? What they did is they take the negative up. When you bring the negative up, basically this whole entire thing changes. And that's what the back did. You can either have the negative on the bottom or on top. It doesn't matter. But I want to go over some homework questions a lot of students are asking for help with. And that was fractions. You have to know how to do this on your exam. Fractions will be tested. You can't be afraid of fractions. The best way to help you out with fractions is do some background knowledge. Let's say if I give you this. X plus 4 over 2 minus 5 equals to 2x plus 1. This is a bit of background knowledge. I'm going to pause it right here. I want to see how many you can solve for x. Try to solve for x on your own with a... I'm going to show you how to work with fractions. A lot of people can't do this, not because they can't work with square roots, just because they hate fractions. So, to solve fractions, the key is to get rid of the denominator. That's the key. The key to working with fractions is to get rid of the denominator. There are many ways of doing this. I'm going to show you one technique. Okay? I'm going to look at the left side because that's where my fraction lies. So what I can do is, actually I can move this 5. Yeah, it makes no difference. Let's just look at the left side to make things easier for now. Let's make the left side one common denominator right now. So we'll make it one common denominator. So make it one fraction right now. So with the left side, would you agree? I can rewrite this as x plus 4 minus 10 over 2. Because what I did was I multiplied this by 2, multiplied this by 2 to make it common denominator. My right side, I didn't do anything to it yet. 2x plus 1. I can rethink of this as saying over 1 if I want to. I'm going to simplify a bit further. That gives me x minus 6 over 2 equals to 2x plus 1 over 1. Back in grade 9, grade 8, you were taught something, a trick. When you have one fraction on the left side, one fraction on the right side, you're going to cross multiply. So what we can do is let's bring this 2 over here by multiplying by 2. Okay, back to you across the technique called cross multiplication. So this becomes x minus 6 equals to 2 times 2x plus 1. Because the key is to get one fraction on the left, one fraction on the right, and then I can just cross multiply. Now somebody asked me, so what happened to this 1? Well, really, if I bring this 1 over here, it's the same thing. It's just saying times 1. So let's expand and solve, please. X minus 6 equals to 4x plus 2. Guys, gals, who's right? And who's wrong? So that's negative 3x equals to 8. Wait, how's it negative? Because I'm going to bring this 4x to the left side. I bring it to the left side. So x minus 4x is negative 3x. Now I'm going to bring the 6 to the right side. So this becomes x negative 3x. X equals to negative 8 over 3. So who had negative 8 over 3? 2 people. 3 people. Wow. Good job. So guys and gals, that's the key to working with fractions. I'm going to give you some more problems for you to practice. Try this. Jason, question.
Or we want to just like do reverse step maths or whatever and just slowly take over each thing.
What do you mean by slowly take over each thing?
Like, instead of turning them into fractions and
Yep.
stuff, can't we just like,
Mul-
beginning plus 5 on the other side? And
You could, and then multiply by 2?
Yeah.
That works fine. I'm just showing you there's many ways of doing this.
Okay.
So Jason asked a good question. Say, Mr. Noah, couldn't I bring this 5 to this side right away? And then that means you have 1 on the left side, 1 on the right side. The answer is yes, you can. Okay. It's just a matter of showing you how this approach is done. Many ways of doing this. There's no right or wrong approach. Guys, let's try this on your own. And I'm going to walk around. I'm going to help you out if you're lost. I want you to solve this fraction. So your fraction is going to be q squared over 2 plus 11 equals to q squared minus 2q plus 1. Right off the bat, I see a fraction. Many ways of approaching this question. One technique Jason says is, Mr. Noah, can I bring this 11 to the right hand side right away? The answer is yes, you can. It makes life easier if you want to do that. Okay? So let's just use the other approach. Like I said, there are many methods of doing this. Q squared over 2 equals to q squared minus 2q minus 10. I'm going to pause it right here and let you figure it out. So guys, I'm going to bring this 2 over by simply multiplying by 2. Again, no tricks. Q squared equals to 2q squared minus 4q minus 20. Now, I want to always, when you have a q squared and a q term, always try to equate it to 0. That's the key. So you have 2q squared. Oh, sorry. I'm going to move that q squared over. That gives you q squared minus 4q minus 20, see, equals to 0. The reason why is I have a q squared and a q term, like that. How do you solve this now? Harmeet. Solve by factoring? Well, what two numbers multiply together give you 20 or negative 20? Add together give you 4. There's no numbers. Pawin, if there's no numbers, what do you do? Complete the square works. But there's another method, more easier, slightly easier. Christelle, what is it? Quadratic formula. Darren, I asked you a long time ago. Do you remember the quadratic formula? You're up.
Negative b.
Negative b, good.
Plus minus.
Plus minus, good.
Square root.
Good.
B squared.
Good.
Minus 4ac.
4ac, yep.
Over 2a.
Now remember, this line right here, some of you made boo-boos before. That line goes from one end to the other end of the equation. So all we're going to do is just sub it in. I'm not going to go physically solve it. I'm just going to sub it in for you so you get an idea what the answer is going to be like. So this will be 4 plus minus 16 minus 4 times 1 times negative 20 all over 2. Take a look what I have up here. I'm going to simplify it a bit further. 4 plus minus. That's going to be 96 over 2. Okay. You can easily solve it from here, but I'm going to leave my answer like this. Or you can easily simplify even more. But for now, to save time, I'm going to leave it for you to work on this on your own. And you can leave this for now. That's fine. But the main reason I want to do this is I'm going to give you a question. I want to see if you can solve it or not. A lot of people asked me how to do 8D online yesterday. So we're going to go through 8D right now. I'm going to pause it and let you have a try at it first. J plus 1 over 3 plus 5J equals to 3J minus 1. Guys and gals, I'm going to pause it. So if you're stuck, I'm going to give you just the first hint. I'm going to move the 5J to the right hand side. Keep it simple, no tricks. So this now gives me J plus 1 over 3 equals to negative 2J minus 1. My whole point of this is get rid of the square root. So I'm going to take a minute and I'm going to square both sides. Squared, square. Okay. If I square the left side, I'll be left with J plus 1 over 3. You can use my shortcut technique here, or you can do it the long way. I have no preference on which way you choose. Jason, if I square out negative 2J minus 1, what would it get on the right hand side?
4J squared take away 2J plus 1.
4J squared.
Take away 2J.
Sorry, I didn't hear you. It's not take away 2J. Plus 1 is correct. What's in the middle? That's where you went wrong. The middle piece. Malika, what goes in the middle? 4J is the middle piece. So double check if you have 4J there. I'm going to pause it again and let you try this on. So I'm going to bring this 3 over. And I'm going to multiply everything by 3. So you get J plus 1 equals to 12J squared plus 12J plus 3. I'm going to get everything to one side and equate it to 0. 12J squared plus 11J plus 2. Now, if you got up to here, we know this is equal to 0. I always try to factor first, and I taught you technique. If there's a constant in front of the, if there's a coefficient in front of the J squared, you're going to multiply this by 2 at the back. So, Lavraj, what are my two numbers that multiply together give you 24, add together give you 11? 8 and 3 is correct. So I go x plus 8, x plus 3. Yuraj, what did I do next?
You put them both in 12.
Ah, good. See, because there's a 12 here, I have to divide both of these by 12. That was my policy I taught you before. Okay. So guys, gals, let's reduce this before we do anything. That gives me x plus 4. Oop, not 4. What am I talking about? Plus 2 over 3. And x plus 1 over 4. I can now if I'm solving for x equals to negative 2/3 and negative 1/4. Now what you're going to do is sub these back into your equation and you're going to test. Maybe one of them will be a reject. Maybe both of them will work. I don't know yet. But I'm going to let you figure out for yourself. And so test your answer now. Your answer. So what we're going to do is we're going to test my answers. That's it. So take a minute, sub it in. If you want, you can try to use the decimal system if you're really, really afraid. But try to work with fractions. Maybe one of them will be an extraneous root. Maybe both of them work. Who knows? Okay, I'm going to pause it, let you test. When I walked around, a lot of you say, hey, look, this number right here is a reject. Or you can call it extraneous roots. Guys, gals, that ends lesson for day block 1.